Hey everybody, I hope everyone's doing well. Let's look at laws of exponents, and in particular, we're going to focus on this quotient rule here. So quotient rule in here, quotient, that fancy term quotient. Remember, quotient is a fancy term for divide. I'll scratch it in here real quick, and you can just write it kind of on the side of your notes. But that's what we're doing, quotient, divide, dividing exponents, and check out this rule we want to follow when we're dividing exponents. So I'm gonna do this basic setup where we have a over m divided by a over n. This will kind of show us how the rule works. So when we apply the quotient rule, what we're doing is this. When dividing exponents with the same base, you must subtract the exponents. So what happens here in our little example that we have, I'm dividing a m divided by a n. Basically, because our base is the same, I have a in each one of them. I'm really just going to take the exponents and I'm going to subtract them. I would take the m value, write that neat. I'd take the m value, subtract the n value, and that would, my answer would basically be a m minus the n value. So let's put some values in, some actual numbers here, and let's kind of check out how this works out. So on this example, quotient rule, I've got 4 to the 6th power. We're going to divide that by 4 squared, 4 to the 2nd power. And like we said, we're going to basically subtract the exponents. I'm going to show you the long form on an example or two, just so you understand why, how it kind of works out. And then you should be able to solve most of them just by subtracting the exponents. But what this means, 4 to the 6th power, remember, is basically like I got 4 times 4, 6 times really, 3, 4, 5, multiplication sign, 6, that's my 4 to the 6th power right over there. And I'm basically dividing it by 4 to the 2nd power. So that's just 4 times 4, like that. Well, basically this cancels out. When you divide out, it kind of cancels out. So I'd cancel out that one. I'd cancel out there as well. And what I have left over is 4 times, or 4 to the 4th power. So it looks like this, 4 to the 4th power, but kind of the easier way of doing that is saying, hey, look, my exponents, if I take the 6, I subtract away the 2, I get 4, I keep the base the same, and I have 4 to the 4th power. So subtracting the exponents. Let's try another one. So I've got variables in here, x to the 7th divided by x to the 3rd again. So this is the same as x 7 times x times x times x times x times x, and I think one more is x to the 7th power right there. And we divide it out by x to the 3rd. So x times x times x. And just like on our last example, when you divide, you cancel them out. So we kind of cancel out there, we cancel out there. What do we have left? Well, we have our solution left. It's going to be x, 4 of them, or x to the 4th power. And just like in our last one, if we took the 7 here and subtracted the 3 there, I can write a cleaner 7, sorry, 7 there, subtracted the 3, that's going to equal 4, and so that's going to be x to the 4th power. All right, let's look at some more complex examples here. So now we've got variables, and we've got some other values in the terms here. 3 to the 5th power, y to the 4th, divided by 3 squared y. All right, well, what's this look like? I'm basically going to look at my term. So I've got the base there, 3, 5, and 2. So I want to subtract there. So I basically have this. I'll write it out again, kind of a long form. So this should look like this. I should have 3 to the 5th power divided by 3 squared. That's that first part of it. And then I'm going to put a little multiplication sign. We're not multiplying, but I'm just showing you how the division works. The other section has this y to the 4th divided by just a y. So I'll write that out here as y to the 4th divided by just a y. And we can basically apply that quotient rule, the subtraction here. So right here, I've got 5 and 2, basically 5 minus 2 there, which 5 minus 2 is going to equal 3. So I'm going to start out with, do this in a darker color, 3 to the third power. And then let's look at this section right over here. Y to the fourth divided by y. Now remember this. Y doesn't look like it has an exponent, but it's always that power of 1 there. So I'm going to put that there because what that means is when we subtract the exponents, I've got 4 minus 1 right there. Of course, 4 minus 1 is also going to equal 3. So that is going to give me 3x cubed there, and then y to the third power. So if we subtract those exponents accurately, we then kind of knock it down to that. All right, so what if we change now the number in the base? So I've got 8n to the fourth power divided by 2n. In the previous examples, we had the same value here and here. We've changed it, so now we can actually do some division there. So now I can actually, we're going to do the same thing with the exponents, but I can actually divide 8 by 2, or the 2 into the 8, however you want to look at that. When you divide 2 by 8, or 8 divided by 2, I apologize, you get 4. So I'll throw a 4 out over here in orange. And then we're going to look at our exponents. I've got a 4 in, well, exponents. I've got a 4 into the fourth power. Remember, there's really a 1 there into the first power. So this is going to be 4 minus 1. 4 minus 1 is 3. So that makes the answer here 4 in to the third power. 4 in to the third power when we divide out the 8 divided by 2. All right, last example, a little bit more complex. We've got 12 x to the fourth y cubed divided by 4x squared y squared. But let's just continue to apply the quotient rule like we've been doing. Like we did in the last example, we can divide 12 by 4 here and kind of get started. 12 divided by 4 is going to be 3. So I'll go ahead and write that down. So now that we've got that done, let's look at the x variable right over here. I've got an x to the fourth power and x squared. So basically, I'm going to take the fourth part and subtract 2. 4 minus 2 is x squared. And then let's look at the y. I've got a y that's going to come in after that. So I'm going to throw my y here. And I've got 3 here, cubed, minus 2. 3 minus 2 is 1, so it looks like y to the first power, but when it's to the first power, we don't write that. We just put it as a regular y, so our answer would be 3x squared y. Final solution right over there, applying the quotient rule. So just remember, when you see that quotient rule, you're dividing exponents. You can subtract the exponents, and make sure you apply that okay, and divide out the first term if necessary right here, like the 12 divided by 4 as a basic review.